So, I don't need to introduce myself, I think. I think it's pretty clear. Basically, I have been given a task of trying to consolidate multiple monitoring environments in a way that a lot of people can use fewer hardware and a more intelligent way of making it failover. So we have a huge number of external proxies, and those proxies connect into fewer servers that are divided in 2 data centers. So those 2 data centers actually synchronize information between each other. The idea is exactly that. It's to have uncompromised access. We have data duplication between 2 different locations, physical locations. We can have multi-component inside this structure, which is like Elastic and Grafana and other things. We have server duplication, so then we can have updates, and we can stop one server, do an update, fall back to another server, and have continuity on that aspect. So we need to provide a methodology for failover and failback, and it should have speed. It should have it should respond fast, and obviously the uptime should be kept at the maximum. On the discovery phase for that, it's not a huge environment like we probably have seen for other people here. What happens is this. Sentia, it's a big provider in the Netherlands, and a lot of things that they do is to buy smaller companies, which comes with different clients, different mentalities, different applications, different ways of seeing things, different things of ask things. So then we have a legacy of too many different products and too many different things at the same time. So there's no standards. We have a variety of things, Zabbix, Nagios, PRTG, AWS, Azure, custom things. There's no framework of ticketing notification that apprises everybody on the system. There's basically no continuity, because if you mess up in a certain location, in a certain hypervisor, that monitoring may crash, the other will not crash, and it's everyone on its own. So there's no centralization, and it's the thing that we want. Initially, on my discovery, I got around 4,500 hosts, something around 600, like 500,000 items, 3 terabytes a year, and more or less 250 users. So that was an initial discovery phase. Now we are in a different level. So the wish is that we want mostly open source. I don't want to get into expensive hardware or things that will create a legacy of a certain product. I want to have open source, pure and simple open source. So, well, let's start fresh. Let's try to do things with a different perspective. Things that contain all those features from Zabbix, Grafana, Elasticsearch, Percona, and Ansible. Things that should be work with multiple data centers, that we can have multiple databases available. How can we keep 10 years of data? How can we notify to multiple systems at the same time? How can we get metrics from everything from the operations? So if there is an event that happened on the monitoring, that will be triggered into an internal system where we can calculate SLA and SLR at the same time, have the reporting for the clients and for Sentia itself. Well, dashboarding is never too much. We can be sure that we can see data in the most easy way as possible. So then Elasticsearch, Grafana should enter into the mix to help on that as well. Obviously, most of this is based on in-house integration. So I was so happy when first saw that Zabbix would be able to start writing into Elasticsearch. It's fantastic. So I spend no time getting a version of Zabbix and start testing, writing data to Elastic. And obviously, people must know that it's not only Elastic that you should use. You should have a MySQL or some other type of application next to it, like Percona, that you can write all the data to it. Then, thinking about that, how can we think about failover? So if we think in failover, isolate the entire platform in one single hypervisor, have all the servers running on the same place, and I have things in one data center. If that data center fails, we should go to a second data center. How are you going to determine that? How you can really be sure that things are being passing by in a certain pace where you're not going to lose data and things will have continuity, that it's required for billing, for make sure that you're telling the truth. A second method is to have a failover on the same data center with two hypervisors. When those two hypervisors fail, you go to the second data center. And there you have two more nodes, two more physical servers that you can use to fail over forth and back. But then obviously this is a much more expensive solution because you need four huge servers that can withstand independently from everything by itself. So yeah, it's a little bit more expensive. So one of the things about data independency is that if you have a server running, a Zabbix server running, and he's writing data into Elastic and Percona at the same time, they should be synchronized to the other data center where there is a standby Zabbix server. We all know by now that Zabbix is unable to run active at any moment. So what you need to do is to make sure that the data is available at any moment. And when your main Zabbix server crashes, you can fall back to another set of cluster that contains the same data. And that's what we achieved. How? Well, first of all, I have an entry point on one data center. It has a local VLAN with the servers that are accessible to me. I have a stretched VLAN between the two data centers where we can send data for synchronize the Elastic and the MySQL underneath. And basically, all the components by itself only communicate between each other inside the stretched VLAN. And there is a failback, which is the standby data center with an internet entry point and a local VLAN for its own. Then, at some point, we start to have this separation. It's not only one Zabbix installation per side. We needed to have a Zabbix installation for our infrastructure, which I don't want the clients to peer upon. I don't want them to connect into my Zabbix. And I have a Zabbix for them. So they have their own interface, and they can have as many interfaces or Zabbix separated that they might wish. So it happens that we have a whole bunch of teams. Those teams deal with different clients at the same time. Everybody uses what we call the global Zabbix. But at the same time, the global Zabbix can be multiplied. So in one server, in one structure, it's visible to have multiple Zabbix servers running at the same time concurrently. And all the data that is being sent to those servers are being shared on a stretched VLAN, synchronizing data underneath it. What will happen is that you need to have basic different MySQL DB names. It's something that is widely accepted. You just go on the configuration and make it happen. You can work with custom ports. So then if you're running one entry point that has multiple Zabbix servers running at the same time, you can separate them just changing the port number. And obviously, for the front end, you can separate the custom hosts, where it's coming and how do you call it. On the other hand, Zabbix Elasticsearch can only run with one server and one index, which means that if I want to have a Zabbix server here and another one running on the same Elasticsearch, what will happen is that when you start this, they will create indices automatically on Elasticsearch. They will have the same name. And that's not good because obviously you cannot peer on the data at the same time on the same index. So then I did a change. I created a fix, which you can see on a small patch that I have published there. You can get the number and have a look on the support page. I added on the configuration a prefix that he's going to create in front of the index that he's going to create towards Elastic. And yeah, obviously, you're going to add the data there. But per day, you're going to have indices with the same name. So if you add a prefix in front of it, everything will work as expected. Yeah, just one thing is that you're going to find out that this configuration also changes the aspects of the front end, because when you're using Elastic, you also need to point the front end towards Elastic. It's not only the Zabbix server itself. So that this will fix both problems here. But then, yeah, the world is an imperfect place, and the universe is only developed because everything is imperfect. And yeah, we start having errors there. What happens is that when I start to put too much pressure on the Elastic, I started to have some problems with it. I start to have some unrecoverable errors, things that you can really not do much about, and some other things that are more recoverable. Why they are recoverable? Because by default, Elastic will accept headers. I think that, will accept headers with a certain specific size on the header. And the minimum length of that header is 4K. So because Zabbix is dealing with a lot of data against Elasticsearch, he's going to create some huge queries, and you need to extend that to 16K. If you do that, you will get rid of some of those guys here. Some of these are more related with the aspect that Elastic takes some time to flush the data, to get the data available back to Zabbix server, and it may take some time. But after all, this not being recoverable, they will dissipate during the operation when he becomes more available, when the data becomes more available. And one of the other things that you're going to start to see is that bulk items starts to get a little bit crunchy. You're going to start to appear that on the log as well. But with time, that will get more stable. So on the other part is the question, okay, you have multiple Zabbix servers running at the same time, and you can fall back between servers inside the stack. How do you do that? Well, most of the people know Pacemaker. That's the most no-brainer, right? It's just there. You just put a pacemaker looking into the systemd, and just let one of them run at the same time. You can have two options here. You can either have using the stretch VLAN to communicate one huge pacemaker cluster and make the four servers discuss in terms of priority who is going to run or last. Or you can use a feature from Red Hat. I think it's from Red Hat. It's called the booth. And there is another node outside that will determine from those two pacemaker clusters who is the one that it should be running at the same time. Continuing to the approach of how do you access that is the fact that you have one DNS entry, second DNS entry. All of them will fall into a HA proxy. The HA proxy will recognize the vhost, which will deliver to Apaches, and the Apaches will have the vhosts pointing to different interfaces inside the system. So then this is one host with an Apache and two vhosts. Same here, same here, same here. So then in each data center, I have two Apaches running two interfaces per type, or more, because then you can just replicate the amount of vhosts with different names and create new directories for it. But that also doesn't work out of the box. One thing that you need to do is that you see that I'm using here version 403. I expect that will not change much from the current version. If it changed, it's because it was added something to point the directory of configuration where the configuration of the front end is. If not, what you need to do is to copy the configuration from the share to the new directory name, the configuration as well. Actually, this is the front end, and this is the configuration. And then you need to edit those files and change the hard-coded directory for the configuration reading here and there. So 2 files, 2 changes. And while you're using the Elasticsearch, you would need to include that configuration for Elastic. And on using my patch, you need to add a history prefix. So then you will separate to each index the specific front end will collect information from. Next to it, the other important part, actually this is one of the things that it's the most pressing point here. You have the DNS entry. Well, imagine, you have 2 data centers underneath it. I really gathered that a lot of people think that load balancing is to have a DNS entry with 2 IP addresses. And then 5 seconds, he's gonna change between A and B. That's not load balancing. That could be some solution to divide the load there, but that's not really something that will relate to a failover. So what happens is that I have a DNS address, call it the Lua address, using PowerDNS. For those who don't know, PowerDNS, it's a system like Bind or some other basic DNS system, but it has way more advanced features, is backed by a database, and has APIs, and it's actually a fantastic system. And one of the things that they have been doing is to include a certain type of Lua RR. This Lua, you can do some programmable logic inside it. And you have some functions like that. And using HA proxy, there is a feature called the monitor, and you can add a certain specific entry, which there is a counting logic. He's gonna say, if my side has 2 Zabbix servers and both of them are online, then I'm okay. If both of them are down, then this is not okay. He's gonna return 400, 500, whatever. And then PowerDNS with Lua is able to change the IP address from one to another. So then the DNS address will always point to the same IP address. He will only change if the health check is bad. And then what other thing that you could use to do the same thing? Well, an F5, a GTM, you could combine the entire stack and have health checks inside there, but the problem is money. It's very expensive. And this is free. So it's happy. So then you're gonna have user and proxies going to the monitor, to the DNS, which has this health check underneath it, and this health check will be deciding to which data center you go. Just check this. There is then the layer of HA proxy that communicate with each other. There can be 2 independent HA proxies or 1 HA proxy that stretches between the 2 data centers because they can communicate, but the idea is to separate, is to have independence. And everybody who will intercommunicate, they will communicate back with HA proxy using similar technologies of PowerDNS to figure out who is up, who is down, based on DNS addresses. Then comes the faction of MySQL and how you're gonna do if it's active-active, active-passive, active-slave, which this is practically the same. There is no much difference. This is something more special because at the moment that Zabbix is writing one of those, you're gonna write it into the other one at the same time, and he will reply saying, I'm done, and then he will determine that it's okay to go. This one will say right here, and write to the other one, it doesn't matter. Just do your thing. It doesn't matter if it's ready or not. I'm just simplifying just to not have a lot of discussion about that. And on this aspect means here, if this one is down, this one assumes no problem. If this one is down, this one, yeah, you need to pass him to be active. This one is almost the same as this, but this requires a lot of more work. Then comes the problem. The problem using Percona XTraDB that I visualized with Zabbix, it's something called the BF-BF XLOC conflict. This is very random. This is absolutely something that I could not figure out where it came from. Not that I investigated a lot, but mainly this table has this type of problem when deleting rows. On the discussion of MySQL, they say that, but then probably this table doesn't have indexes. Oh, it does. Everything seems perfect, but when there's pressure, something goes, and I cannot determine when. So the solution that I did was to actually, instead of doing active-active, this is the most approximate thing that would release the pressure from that problem, and I can synchronize data in a way that's passive. The difference really is that when you're doing active-active, he wants to make sure that the data that is sitting on the second active is absolutely perfect to the point from one another. They should be a mirror, an exact mirror. And my theory is that when there is a lot of problems being written, or actually deleted, they cannot match because there is something that is happening with the ID of the problem during the write of the table. And they just get misaligned. So when he's trying to find the problem to delete with the same ID, the ID doesn't match, boom, he's dead. When he's doing like that, the ID doesn't matter. So then he's gonna write here, write there. If it's out of order, the ID is different, it doesn't matter. In the end, he will find it in the same way. Active slave, it would take more time, and the failover would not be perfect in a sense. If I remove one, the other one would assume perfectly. That's not going to happen. So other observation is the fact that Percona requires an arbiter. And what happens is when you're running multiple nodes of Percona, you must have an arbiter per group of cluster. And if you're trying to separate clusters of Percona, my time is gone. I will try to speed up. It's almost the end. And when you try to separate the cluster from Percona, you need to create a pacemaker cluster that has an arbiter on each side. So when you're stretching the pacemaker between data centers, you can do two pacemaker clusters and have the buff cluster ticket manager from Red Hat to control that. Elasticsearch, if you have the latency too big between the two data centers, you can use the cross-cluster feature. Kibana, Grafana, Zabbix front-end, and everything can run on the same instance. Like you can create virtual hosts to everybody, and everybody can run at the same time. All the communications of the internal components is stretched VLAN. The service configurations are deployed all by Ansible, so it's also easy to manage. MySQL load balancing can be done via HA proxy as well. Ingestion pipelines, you need to make sure that you are doing the proper indices rotation inside Elastic, otherwise you're going to have a problem of too many shards and it's going to break. And Grafana has no compatibility with Elastic. I'm just going to explain that fast. If you're writing history and logs and integers to Elastic, they only contain the host ID. And when you're looking into the configuration via Grafana, he will not understand where the data is. So then he cannot match the information properly. You need to do some more work behind this. So on that aspect, right now, Grafana, if you're going to use Elastic, they are not specifically compatible. So for us, the idea mostly is to export the configurations, understand them, create templates, make the import of those templates on a new server, give a new proxy to the new destination. That guy, oh, I want to migrate a PRTG, take a proxy, export your configuration, put everything there, and then let's create an ACL that has a cascading harmonization that your users can see only what the users can see. You have, so then, in conclusion, it's feasible to have a multi-data center that will work perfectly. You can remove one data center of the equation, he will fall back to the other one, fall back, and everything will work perfectly. You can use Elastic, active. You have multiple forms of different, of changing the configuration implicitly with, you name it. You can go wild and have a multitude of ways of doing this. Well, increasing proxy buffers to make sure that if your entry point is down, you can keep some of the information on your proxy and then flush it back when he's come back online. And obviously keep in mind to make sure that all the data centers have as most as possible independency. And that's it. Sorry, too fast.